Hello and welcome to Math with Mrs. Havrilla. This is Mrs. Havrilla and today we're working on the Unit 4 Lesson 12 homework sheet. In our lesson today we continued working on division, and specifically we were working on something called the partial quotient algorithm, which is just a strategy for dividing. On our sheet here, one thing that's important is it does tell us at the top the names of each of the numbers that make up a division equation. We use these words a lot during math, so it's important for us to know. The first number in a division equation is called the dividend. The second number in the equation is called the divisor, and the answer to that equation is called the quotient. So we take the dividend, we divide it by the divisor, and it gives us the quotient. For number one, we have a problem here, and I've actually written it out on my board so we can see it a little better. And it says, for one, that Charlie started to find the value of a quotient. So here you can see he has his little number set up in the typical way for division, and he's got some work here. But the first question is asking us, what is the expression that represents the quotient that Charlie is finding? So what's the equation that he's doing right now? Well, I can find that out by looking up here above. Anytime I set up my division equation and I'm building this sort of L-shaped house, I like to call it, inside of that house is that dividend. The dividend being, again, the first number in our division equation. And it even tells us here on the side with the little house kind of built in. So we know the dividend is going to be 175. And then when we look on the outside here, we see a 7. So we know the divisor is 7. That means if I were to write this equation out, it's 175 divided by 7. We don't yet know the quotient. That is what Charlie is trying to figure out. So for that problem, what we would do is, or for A, what we would do is just write in this equation, 175 divided by 7. And then B is telling us to complete the equation. So I'll go ahead and erase this part so that we can finish what he's doing. Charlie is doing the partial quotient algorithm, and he's used this little arrow to point at each of these products that he's got going on to the side. But what I like to do is I like to actually separate those equations from the rest. So I always draw like a long tail down so it's separate, and I like to put that in parentheses. So now my 10 times 7 here, making 70, gives me 105. 70 is less than 105, which means I can do another 10 times 7. And that's going to give me another 70. When I subtract that, that's going to leave me with only 35 left over. So now with my 35, I'm trying to think, how many times can the 7 go into 35? And I know that 5 times 7 is going to give me that 35 to subtract. And now I'm at 0. So now what my goal is to actually get an answer. And I have to figure out, well, where's the answer here? I'm at 0. 0's not the answer. So where is it? The answer is in how many groups of this divisor, the 7, I was able to make. Well, with the first time I subtracted, I made 10 groups of 7. The second number I subtracted was another 10. And the third group I subtracted was 5 groups of 7. So what I'll do is I'll add 10 plus 10 plus 5. And that should give me my final answer of 25. And you'll want to make sure that you put all of your work there on the page, and then designating your 25 sort of with a square around it is what I usually do, just like they did up here at the top for the example. All right, moving on to the back. Onto the back, we can see that there is an equation set up, and what it wants us to do is it wants us to fill in the blanks. So they've sort of started using the partial quotient strategy here, and we have to finish by filling in those blanks. So the first thing that I'm going to fill in is my divisor and my dividend. The divisor goes outside, the dividend goes inside. And the whole premise here is that I'm trying to figure out how many times 31 goes into 868. And I can see that they've got some work here done for me already. So they have 310 that they subtracted. And then off to the side, I see they have their divisor, 31. But it doesn't tell me what they multiplied to get 310. So I'm gonna have to figure that out. Then they did the same thing. They got their answer. It's blank. We don't know what that answer was. And they subtracted another 310, and they have that 31 times blank off to the side again. And then they did that another time, but this time it was 248 that they subtracted, not 310. And we had to figure out, well, 31 times that blank is supposed to be giving us 248. That's a blank. Okay. So now that I've got this kind of written out here, I can go ahead and start filling in the blanks. The first one I'm going to fill in, to me, very obvious, is this one here. I have 310 that I'm subtracting, and I'm multiplying my number times 31. So to turn 31 into 310, I can see 31, but there's a 0 on the end. So that means all I have to do is 31 times 10. That means I'm going to be doing that here as well, since this one's also 310. So I can fill in 10 times 31 on my paper, knowing that that is going to give me 310. Next, I'm going to go ahead and do the subtraction. So I know this one is 868 divided by 310. So I'll go ahead and subtract, and it looks like that's what I end up with, 558. And again, I had that 310, so I don't need to really do anything else yet. Sorry, I'm gonna go back and change the color there so that's a little more obvious to you guys at home what I did. I filled in this blank here, just like I filled in these two blanks on the paper, so 558. I'll fill it in over here on my paper, 558. So once I fill in this blank, now I'm gonna fill in this blank, which means I'm just gonna subtract again. So 8 minus 0 is 0. Oh, sorry, 8 minus 0 is 8, not 0. 5 minus 1 is 4, and 5 minus 3 is 2. And now I can see, oh, these two numbers are the same, which means that when I subtract to finish, it's gonna be 0. So on my sheet, I can go ahead and fill in 248, and I can fill in 0. But I still need to figure out what number times 31 is going to give me 248. In order to figure that out, I'm actually going to look back at that 310, because I know 310 is more than 248, but they're kind of close to me. So I know that whatever number I'm going to be multiplying is going to be less than 10, but it's not going to be too far away. So if I'm imagining that 310 and I need to get to 248, well, one group of 31, let me kind of write this down here off to the side. One group of 31 and another group of 31 is going to give me 62. Well, if I did 310 minus 62, let's see if that is going to give me 248. It's going to require me to do a little bit of regrouping here. And it does. It gives me 248. So that means if I had 2 groups of 31 that I took away from my 10 groups of 31, I'll take 2 groups away from the 10, meaning that this is 8. 31 times 8 gives me that 248. So I'm going to go ahead and fill that in over here, times 8. And now the last thing that I'm going to need to fill in is that final quotient, that final answer. So that means I have to add together all these groups of 31. So 10 plus 10 is 20, plus 8 is 28. I'll put 28 above with a square around it. So making sure I put that on my paper too. All right, so we have now filled in the blanks for this partial quotient strategy. All right, moving on to number 3. It says that we're going to continue to use this partial quotient strategy, and this time it's just giving us the equation. It's not giving us any work, not giving us any blanks to fill in. We are just going to solve it on our own using our own partial quotients. All right, so let me go ahead and write it out. It's 1,248, and it's being divided by 24. So here's my dividend, here's my divisor. I'm looking for the quotient. In order to do this, I'm going to think of numbers that are easy for me to multiply, that get me close to what I've got. So here, normally what I would do is I would underline the first 2 digits to see that it's 12. I know that 24 cannot go into 12. So that's not quite gonna work. However, I know that 12 is half of 24. So instead of working with 10s, perhaps I can work with 5s. If I know that 12 times 100 is gonna give me 1,200, okay? Then I know that I could do 24, which is double 12, times 50, which is half of 100, and that is also going to give me 1,200. 24 times 50. So I doubled the 12 to get to 24. I halved the 100 to get to 50, so that both of my equations would be the same. So that means I'm going to take away 50 groups of 24 here. So I'll go ahead and write that off to the side. So my 24 times 50. Sorry. 24 times 50. Well, I could do 24 times 100, which is going to be 2,400. And then I just split that in half, and it gives me 1,200. Finish that parenthesis there. I'll go ahead and subtract. That leaves me with only 48 left over. So now I'm going to go ahead and do 24 times 2, and that's going to give me 48, subtracting to get to 0. Now, if you did not know what 24 times 50 was by using that halving and doubling logic that I just used, You could have started with 24 times 10 or 24 times 20 and just worked your way up to that 50. Now that I have myself at 0, I'm going to look and see how many groups I have. I've got 50 groups of 24 and then 2 more groups of 24, which means I have 52 groups of 24. I'm going to go ahead and make sure that is in a rectangle on my page, designating that as my final answer. All right. Last, we have some spiral review here. So we have a multiple choice question that's actually going to ask us about fractions. And since we started our year with Unit 4, that means we actually haven't done the unit in which we're doing fractions. But thankfully, we're familiar with fractions from 4th grade. When I'm taking a fraction, so for example, A, where I have 3/4, and multiplying it times another fraction, so this one's A, what I'm really doing is I'm multiplying the numerator times the numerator, so 3 times 4, and the denominator times the denominator, 4 times 3, which means I end up with 12 12s. Anytime that numerator and denominator are the same, it equals 1 whole. Now the question for number 4 says, which expression has a value less than 1 whole? If A is equal to 1 whole, then it cannot be A. So I'm going to cross that one out, striking through A. I'll move on to B. With B, I have 3/4 multiplied by 6/3. Again, I'm multiplying straight across. So 3 times 6 is 18. 4 times 3 is 12. And when I simplify that, I know that there's one group of 12 in there. And then there's another 6 left over, 6/12, which is actually equal to 1/2. So I've got 1.5 here, which is greater than 1, not less than 1, so I'll strike through the B. For C, I had 3/4 times 4/4. Now, right off the bat, I'm going to guess that this one's my answer. Why? Because I have a 4/4 here, and anytime I have 4/4, or anytime I have a fraction that's the numerator is the same as the denominator, it equals 1 whole. And any number times 1 is that same number. So 3/4 times 1 should be 3/4. Let me go ahead and see if it works. So I've got 3 times 4, which is 12. And then I have 4 times 4, which is 16. I could now simplify that by doing 12 divided by 12 divided by 4 to get 3. And 16 divided by 4 to get 4. So it is equal to 3/4, which is less than 1. So just to be absolutely sure, I am going to check D to make sure it is not less than 1 as well. So I'll do 3/4 times 8/4. Multiplying straight across, 3 times 8 will give me 24. And then 4 times 4 is 16. And I can see here that my numerator is greater than my denominator, which means that it's definitely going to be more than 1 whole. In fact, when I simplify, there's one group of 16 with 8 left over. 8 over 16 is going to be equivalent to 1/2. So that one also equals 1.5, which means I'll strike out D and I'll select C as my final answer, the only one that is less than 1. Now, on your homework, make sure you're showing me next to A, B, C, and D all of the work here so that I can know that you're absolutely sure that C is that correct answer. That is all that I have for you today. So be sure to check in again next time for help with your homework.